In the last video, we got our CodeLab running and opened SSH tunnels to our CodeLab machine on ports 9000, 9090, 8084, and 8087. For this video, we'll start with a Spinnaker UI on port 9000. We'll introduce the core Spinnaker concepts, map these to Google Compute Engine concepts, and build our first pipeline. Here we're going to create our first application. An application is associated with configuration details and also namespaces the resources that we deploy. An account here is associated with a set of credentials for a cloud provider and some configuration details. For this CodeLab and for the Google Click-to-Deploy solution, this is already set up to deploy resources in the same Google Cloud project that Spinnaker is running in, but this is all configurable. There are a few core Spinnaker concepts which are prominent in the UI. I haven't deployed any resources yet for this application, so all these tabs should be empty at first, but we'll populate them soon. We'll create a load balancer for server groups that we create in our pipelines later on. The stack and detail fields are freeform, but could be used to indicate whether it is a test or production load balancer. We can define which ports to forward. In our case, 8080 is correct for our sample application, and the listener here can be a range. We're also going to define a health check endpoint. The field at the bottom of the form are parameters for how the load balancer should evaluate the endpoint and deem an instance unhealthy. In terms of Google Compute Engine concepts, a load balancer is an association of a forwarding rule, a target pool, and a health check. We're going to create our first of 3 pipelines. We'll name this one Bake and Deploy to Test. Our pipeline is going to be triggered by the Jenkins job we looked at in the previous video for this CodeLab. One thing to note here is that pipelines can be triggered not only by Jenkins job, cron triggers, or GitHub webhooks, but also by other pipelines, which we'll do later on. Next, we'll configure a bake stage. Spinnaker's internal bakery service relies heavily on Packer. The goal here is to take the Debian package produced by the Jenkins job and turn it into a machine image that we run on our server groups. We'll specify the name of the package without version identifiers and also the base operating system. Finally, we'll configure the server group that we want to deploy. Inside the wizard, you'll see Spinnaker abstractions and resources such as security groups and load balancers, as well as low-level provider-specific details. In the load balancer dropdown, you should be seeing the load balancer called CodeLab Test you created earlier on. You'll also need to pick a zone in the machine type. Note that we're not specifying a machine image here. In the pipeline stages, we often let the image be determined by context. Spinnaker knows to look to upstream pipeline stages. In this case, the bake stage provides the context. In terms of Google Compute Engine concepts, a server group is a managed instance group. We should be ready to actually run our pipeline. I'll speed up this video periodically as the pipelines can take some time. Remember that the Jenkins UI is running on port 9090 and that the username and password are both admin. I'll manually trigger the Jenkins job, though we'll trigger it again with a git commit later on. After the job is run successfully, we should see our pipeline start inside Spinnaker. The Spinnaker UI provides details on the progress of each of the pipeline stages. We can also click on the link to see the baker's updates. Note that the bake stage may take up to 5 minutes. Our bake stage has completed successfully, and Spinnaker is now deploying our server group. As it's coming up, take note of the details the UI provides. We should be able to inspect fine-grained details for both the server group and the instances inside it. Details about launch configuration and also information about the health of the running instances. If we've configured everything correctly, the little rectangles underneath the server group header should be turning green. This indicates that each instance is healthy. During the next video, we'll create 2 new pipelines that will simulate the promotion of an image to production.